So, okay. Yeah, good afternoon to all. I think that the wrong picture in the background, the last day of winter wonderland here in Berlin, I think. So enjoying it for the last hours here. So I'm glad to introduce Nora Götze. Nora Götze studied classics, and so we know us from several courses here at the Humboldt University, and she studied computer science. It's a quite rare combination of subjects, and one very interesting for us here, and not only for us, I think. It has made it possible for her to collaborate in several ancient studies projects at the Berlin-Brandenburg Academy. You told me Galen project, Inscriptiones Latinae, Telota project of Inscriptiones Graecae. And in particular, she programmed various tools for the required digital processing. Currently, she is freelancing, and she, as she told me, is working on a tool to edit text and translations of the inscriptions on the website. I get that your presentation is something to do with this project, and therefore I'm looking forward to what you can tell us about the possibilities of machine translation in our work area. Translation bots are particularly exciting, and perhaps an unsettling area of AI for our profession. I'm very unsettling. So please start your presentation. We are all looking forward, I think.
Yes, thank you. I don't think there's reason to be afraid yet, but we'll see. I don't really know if there's is there something I want to share my screen.
Yeah, okay.
Is there something I should? I can just.
It should pause it for you. I can look, but.
Wait, Nora, make you co-host, and then it should be fine. Yeah, you should be able now to share the screen, Nora.
Okay, just a second.
Not possible, but for you, I hope.
Just press on Bildschirm freigeben oder share screen.
Okay.
Yeah, perfect.
Okay, now.
Okay. So, I will admit this right at the start. I am actually not an expert in machine translation. It once seemed like I was going to be. My training, as Roland said, was in Latin philology and computer science. And one question I would have to answer quite regularly was, why would you combine the two? Is it because of the logic? People who had done Latin in school would go on about the rigorous structure of the language and inevitably about conjugation. Over time, I actually accepted this as truth. And when I met a text that appeared to follow all the rules, I ran circles around it for years trying to get a machine to translate it, until I stopped, and we'll get back to that later. The idea of a universal translator, a piece of technology that allows us to talk to anyone without having to learn a new language, is, of course, very old. As a research field of modern computer science, it is pretty old too, and it has a remarkable origin story. Remarkable in that it already contains, in a general fashion, every problem machine translation researchers encounter up until today, and also every solution being applied to these problems since then. On top of that, it shows a mindset still going strong in the field today. The story goes like this. It doesn't do anything. Now it does. The Second World War, a fertile breeding ground for applied mathematics, especially cryptography, and a flood of research literature in the years after, inspire this guy, US-American mathematician Warren Weaver, to sit down and contemplate the application of cryptography to the problem of the enemy's research being in the enemy's language. Weaver, as he points out himself, is neither a linguist nor a cryptographer. He still manages to generate a lot of attention with his memorandum on translation. You can find it at this address. Weaver argues that language is an artificial creation of mankind, making use of the human of the human body's general ability to speak, a tool to discuss things that are important to human beings. Our shared human experience suggests that there is a common core to all languages from which we can work to transform one language into another. So hypothetically, a Russian text is nothing more than an encoded English text. According to Weaver, there are 4 basic problems to be solved so that we can advance from using the machine as a mere bilingual dictionary to actually having the machine translate a text for us. These are differences in word order and sentence structure between source and target language. For example, the default order for English main clauses is subject, predicate, object, while in Latin it is subject, object, predicate. Second, fixed phrases that cannot be translated literally, like this legal term, aqua et igni interdicere. Apparently, it means that a person is banished and other people are not supposed to help that person. We cannot translate it as they are forbidden fire and water. Third, ambiguous words such as cum, which can act as a preposition or as a subjunction, and quam, which may be a relative pronoun or indicate a comparison. And fourth, illogical elements. For example, here we have an ellipsis where Cicero tells Atticus that someone asked whether he'd heard any news, but leaves out the actual asking part. And here are the solutions. For sentence structure differences, there should be rules to transform the source structure to that of the target language. Phrase dictionaries for each language pair will solve fixed phrases. Word sense disambiguation may be done by checking a range of words of immediate context up to the whole text, statistical approaches, or with the help of neural networks. And for illogical elements, we shouldn't try to have a machine translate any literary text. Machine translation, according to Weaver, should be restricted to research because, of course, research literature is completely error-free and not illogical at all. So there you are. Weaver has thought of everything, and machine translation must be just around the corner. I want to focus on the circumstances of this story. What do we have here? A mathematician builds a model of a generic language and then tours as far as he can reach to get people to build a machine translation program. The people who he talks to, and I have to stress this, are not linguists. Some of them even argue the non-feasibility of machine translation, like Norbert Wiener, a cryptographer from MIT. But Weaver is not phased at all, and thus a whole new field of research is born. Its enthusiastic participants convinced that yes, machine translation is just around the corner. And yet, here we are, 70 years later. That is not to say nothing happened during this time. In fact, so much has happened that it is impossible to recount every approach, much less every project. To anyone who is interested in the specifics of lots of systems, I can warmly recommend the Machine Translation Archive by John Hutchins, a very thorough librarian, at this address. The archive has thousands of articles from the beginning to 2017, from which point on there are no further updates, unfortunately. It appears that Hutchins was ill for a while and now has died at the beginning of this year, so I'm guessing that's it. I will describe some of the more influential approaches as best as I can and without going into too much detail. It seems appropriate to start with the Interlingua approach because this is where Weaver's idea shines through most clearly. The Interlingua is a language of concepts, the aforementioned common core of all languages. There is no ambiguity, no implicitness in an interlingua. It is, in theory, everything that language can express. Scientists have come up with different ways to model this, as networks, as graphs, as grids, with symbols, with bracket notations. And we'll use an early one now and go with the bracket notation here because it's perhaps most intuitive. Take the sentence, I went to the library to fetch a book. I is on its own as subject of the sentence. Went is the predicate modified by two adverb phrases. To the library, indicating a direction, and to fetch a book, indicating a goal. Now we're replacing terms by interlingual concepts. I is represented by this person. Went becomes past go, while library and fetch are replaced by combinations of universal terms. Book, storehouse, and carry back. Note that while we're doing this in English, it is actually meant to be terms beyond the English or in fact any language. At last, we're making explicit the meaning behind the structure, as you can see by the addition of purpose behind back carrying to replace one of the two twos, and wards to replace the other two. The addition of is at the end qualifies the term as a main clause. The idea is that now, as these groups of universal content float around freely, the machine only has to translate each now unambiguous word and then arrange the groups by the rules of the target language. As far as I know, none of the several proposed interlingua has made it to even a functional machine translation system to this day. It's probably to do with the analysis and disambiguation part. Rule-based machine translation is like the proper linguistic approach born from the idea that we can somehow copy the human translation process. One would think that these are the steps a machine should take to translate a text. First, we have some sort of analysis of the source text. Understanding would be what we do and is probably a bit much to ask of a machine, but capturing may just do. Next, some routine should be in place to transfer what the machine captured from the source language to some kind of language pieces in the target language. And last, a new text should be produced in the target language. That's the synthesis. The developed systems differ widely. However, in one way or another, they try to complete these tasks. First, to read the text and split it sentence-wise. Then to split every sentence into word and every word into morphemes. Those have to be lemmatized. In another process, the sentence has to be split into syntactic units. The relationship between these syntactic units have to be found, and the structure has to be stored in some meaningful way. Each lemma needs to be translated. A correct syntax for the target language has to be applied to the stored structure. The correct forms have to be generated for every word, and in the end, a correct and human-readable output should be written. There is some vagueness as to the scope of the transfer part, and sometimes it is contained in the analysis and or the synthesis part. But overall, this is what happens in rule-based translation systems. Some of these have had a moderate success, but they are high maintenance because language is constantly changing and they are prone to overfitting. That is, when you try to accommodate that one text to the dot and lose other texts in the process. The path of least resistance approach to machine translation, circumventing or at least minimizing maintenance, is that of model languages. The idea is that the machine does not translate a free text, but rather that a restricted text is produced to be translated by the machine. There is a fixed grammar for all of the involved languages, like this one, for example, and a set of rules to translate them. This can be okay for any kind of functional text emerging in an industrial context, like a specification or a manual, or other texts with small sets of recurring phrases. It produced the world's longest running machine translation application, the Canadian Meteo for weather reports. I would like to go back now to my rule-abiding text that I mentioned in the beginning. Back then, I was thinking, isn't the Latin language as we know it today a special case of a model language? A dead language is a fixed language after all, and we have all these grammar books and dictionaries describing it all in detail. There's a steady flow of smaller, unedited text. There's the digest of Roman law that is still being translated into German. We could use a machine translation system, couldn't we? In an epigraphy class, I got a first look at the Senate decree on the elder Piso, a 90s sensation in the world of epigraphy. It is an insane story. Among other things, the Roman Senate under Tiberius decides whether it was right that Piso had taken his own life before he could be sentenced for the murder of Germanicus Caesar, around which there is some kind of conspiracy that we had heard of before, mostly from Tacitus. It is our first complete Senate decree, proving Mommsen's so far hypothetical formula of how they looked. But above all, I have to say, it is a beautiful text. So many subordinate clauses, embedded and everything, and almost all of them are textbook perfect. They start with the subjunctive, take a series of objects, adverbial phrases, and further subclauses, and they end with a predicate, a finite verb form. I mark this tiny subclause here because it's like the smallest unit in the text. It should be every machine translation researcher's dream. And yet, I was out of my depth almost immediately. The automatic annotation was a complete nightmare. The available tools were not comfortable with phenomena that classicists, especially epigraphers, have to deal with regularly. Abbreviations, mistakes on the part of the stonemason, the lack of punctuation, missing letters. To even get this text into a digital shape worth translating, someone, in that case me, had to understand it and amend it for the machine. I ended up doing the whole annotation by hand. Writing the translation rules was an exercise in the art of grammar, because it turns out that there is a lot of gray area. And just because I can infer a cause of action from a grammatic rule, it doesn't mean at all that a machine can do it too. The rules need to be very detailed, and as soon as you get one sentence through, you lose another. This sentence that you see here is what I managed in the end, with several years and several thousand lines of code. And the German translation was not pretty. So now you know why I stopped, and we can all go back to what we're here for. The most successful approach to machine translation so far is also the one least concerned with actual human language. Statistical machine translation is like the brute force method, based on heaps of data and raw computing power. The machine translates on the basis of models. First, it learns language models for all involved languages. A language model emerges as a result of calculating probabilities over a large number of texts. These may be probabilities for a word to be in a specific position, or for several words to appear together as a phrase. There may be learned word classes too, but everything is statistical and none of it is linguistic. Second, the machine needs to learn a translation model for any pair of languages. This translation model relies on parallel texts, that is, existing translations between the languages and lots of them. It may contain, and they have to be sentence aligned too. This model may contain the probability of one word or phrase being the translation of another, the so-called fertility of words, when, for example, English not aligns to French ne pas. It has a fertility of 2. It may contain a distortion value that says something about if you would put the original sentence next to the translated sentence, how far away a phrase might be from its translation. Now, having learned all this, when the machine starts on a new text, it actually tries to compute a translation. What words or phrases are the most probable in what position? There may be further guidance in a penalty system. For example, as a rule, whenever possible, choose translation with fewer fertility or with less distortion. Statistical machine translation is eerie in what it can do, as long as you ask of it only stuff that it has seen before. It ill-equipped when dealing with anything that is not statistically significant. The complete dependence of both the language and the translation model on existing data entails another more fundamental issue. While a computer-based translation system without human intervention may sound neutral, it is in fact anything but, because the texts are man-made, and I am deliberately using this word, and they carry with them an implicit bias that continues through language and translation modeling into the new target language text. In fact, a statistically significant bias is even amplified by this process. We can see that, for example, in the translation of genderless languages like English or pronoun-dropping languages like Spanish into any language with explicit grammatical gender. I'm sure you've seen examples like this. Like, as long as it's my secretary, it must be a woman, even if it's he at the beginning. But as soon as it's a secretary of state, it is probably a man. So this is only the gender bias I'm talking about, but obviously there's more. The bilingual texts on which the machine is learning, they are mostly texts from multilingual parliament sessions or international law documents. I'll leave it to you to think about who might be talking and what they are talking about, or rather what they are not talking about. There are further ideas for which we don't really have time today, but anyone interested may want to look into them. Example-based machine translation in its simplest incarnation relies on a bilingual corpus and tries to find text pieces that match the ones to be translated. Interactive machine translation simply involves human translators in pre- or post-editing positions during a learning phase or crossing over into computer-aided translation. Hybrid machine translation wants to combine the advantages of statistical and rule-based machine translation. And neural machine translation is like the latest thing. It adds context, statistically predicted context, as well as currently active context to every word that it translates. So it's basically a kind of layering process of statistics. You start at one word and then you go through the whole sentence. And you can always go back, like if you're looking for an antecedent for a relative pronoun or something. So it is going up from the phrase level translation to the sentence level translation. It is almost exactly what Riva imagined, but then again, Riva imagined that we would be able to disambiguate using the whole text as a context for the disambiguation process. With all of these systems, however, it is important to note that they operate up to the sentence level only. Any kind of context beyond the sentence level is lost. So, in conclusion, I want to put together what we have. Since about 70 years, we are trying to build a machine translation system. There are rule-based approaches trying for an approximation of human translation, but these systems have to be extremely detailed and need a lot of maintenance to keep up with human language. Then there are data-based approaches trying to compute a translation by probabilities, but these systems cannot work with anything that is not statistically significant in relation to data that is skewed and does not represent the whole of human language. Efforts have been made to combine the two, but today none of these systems translate as a human translator would. Which brings us to the question of what we actually want, because as normal people, we want to understand a text in a foreign language that we do not know. Do we need this text to be 100% human-like translation? Can we not already do this with what is available? As scientists, if the article is not already in English, we want an accurate translation. In certain areas like medicine, lives may depend on this accuracy. But again, do we need this text to be 100% human-like? Isn't it more important that we get all the information that was in the source text? Now let's assume that at some point in the future we get routinely machine translated texts that sound like a human translator created them. Who takes responsibility for mistakes that the machine made? They are built by human beings after all, and nothing that is human built will ever be completely error-free. So is it really worth the effort? I want to finish with another piece of history. In the 1960s, the US government installed the Automatic Language Processing Advisory Committee, or Alpac, to get to the bottom of the machine translation efforts of the time. And this is what they found. The committee is puzzled by a rationale for spending substantial sums of money on the mechanization of a small and already economically depressed industry with a full-time and part-time labor force of less than 5,000 people. So this takes into consideration the many actual human translators that can't get a job. Instead of wasting money on machine translation projects, they suggested different ways to use computers with regards to language. And these are actually pretty helpful for the time, I think. It is first to teach foreign languages more effectively, to teach about the nature of language more effectively, to use natural language more effectively in instruction and communication, to enable us to engineer artificial languages for special purposes, to enable us to make meaningful psychological experiments in language use and in human communication and thought, and to use machines as aids in translation and in information retrieval. After this Alpac report, funding was shut down for decades in the US. I'm just going to put that out there. And that's it. Oh, ich kann nichts hören.
Nora?
Jetzt höre ich was. Hallo?
Ah, okay. Ja, ja, wir haben nicht gesprochen. Es gab nur ein bisschen, there was only silence for a bit.
Ach so, okay. Aber Herr Baumgarten, Sie sprechen doch. Ich höre Sie nicht.
Jetzt?
Jetzt höre ich Sie.
Okay. Irgendwie meine Maus funktioniert nicht richtig. So. Yeah, much thanks for your very interesting and I think for me illuminating lecture. Maybe there are questions for seek for more light in this context. So I hope can I see here questions in our gathering here? No one.
I would have a small question if no one else has yet a question.
Yeah, you
hello?
can. Julia, hello?
Yeah, thank you so much, Nora, for your lecture. I have a question on the last slide, actually. Mm-hmm. The one point was to enable to engineer artificial language for special purposes. Mm-hmm. And I would wonder what would be a special purpose in that case.
Oh, there's lots of examples for this, really, mostly from like the tech industry, like from car industry or something like that. So if you have you're using a machine and you need, or you want to build a machine and you need specifications for that, and the machine is built all over the world, then you need to translate that specification. And
okay.
Then you could restrict your language so that it can easily be processed by a machine. So this is and the weather report thing is another example for this. They create texts that are so restricted that a computer can learn the rules quite easily to translate them.
Yeah. Thank you. Thank you very much. Like instruction texts, basically.
Yes.
Yeah.
But as I said, in theory, as soon as you can describe a whole language, in theory, it would be possible to translate it. However, as I have learned the hard way, most languages are so complex that at the point where you have done the complete, like when you are ready to describe it completely, you have already translated the whole stuff. So there's no need for translation for statistical or any kind of translation anymore as soon as you have learned the whole language, because then you can just
do yourself, basically.
Yes,
yeah,
you can just do it yourself.
Yeah. But in principle, if machine would be able to produce translations similar to the humans, then one could argue perhaps that the translation process would be faster.
It would be what?
Faster.
Okay, yeah, that's an argument that's come up quite often. But in the end, if you have to have a person looking over that text to, then it's okay as it already is. So you have all these tools now available that can help you, get rid of a reasonable amount of work. But at some point, you still have to look into it. So you have to look at the text. So yes, of course, but the machine translation systems make everything easier and faster, but they do not enable us to get rid of humans.
Yeah.
And they shouldn't.
Yeah, I agree.
Yeah.
Thank you very much.
Yeah, thanks. Konstantin Schulz, I think, the next.
Okay, so you said a bit about the models and the problems that the various models had, but I'm also interested in the data and that they are trained from. And I think for ancient languages, we have the problem that there is little parallel data, little parallel corpora, where you have one Latin text and one English translation, or one ancient Greek text and a German translation that are aligned by sentence. And would you say that until we create more parallel data, we are basically unable to train better machine translation systems?
That's if you want to do it the statistical way, yes. Then that's the only way to go. You need to parallelize texts. But as I said before, at the point where you have enough parallel texts, you have probably gone through all that we have. You know what I mean? We have a lot of texts in the Latin language, but it would have to be more than that to train a computer to translate this language. It's not enough, even if you have parallels for every Latin text that we have.
Okay, but then if I may ask another question in this direction, but there are some approaches in neural machine translation where they use transfer learning, and they have those triangles of languages where you have maybe English, German, and Latin, and you have parallel texts for Latin and English, and for English and German, but not for Latin and German. And then the machine can learn from the two directions to infer basically the third direction that is not available yet. Wouldn't this be
pretty
applicable?
old, actually, yes. That's why you could see in the Google translations pretty often suddenly English pops up in parts of that you're trying to translate, and you weren't even aware that English was somehow involved, but they were using that as like intermittent language, yes.
And I mean, Latin was basically the lingua franca before English. So there should be a lot of translations from Latin to many different languages in the world. And maybe we can combine other languages to help the directions that we are actually interested in, which are maybe Latin and English or Latin and German.
You can always try. It's just really, I wonder if it's worth the effort. because at the end you also have to look into what these texts really are, because they're somewhere between like non-fictional and fictional texts. They are a little bit of literature, and whatever you get from, so you have to see that you don't have any language that is isomorphic to another language, so there's always this little gap that you have to close by interpretation. And I think you will not be able to get around that. I don't think that it's possible. But of course, if you the thing is, if you put in everything that we know of the Latin language, we already have the whole Latin language. There is nothing more to be translated.
Okay, thanks.
Okay, yeah, thanks. Yeah. Any other questions? Yeah. So, okay, I have one question. I spent some time in a project with translation studies, and we tried to create something like a vademecum for a good translation, and we were very frustrating. As a, I must confess, we thought it's impossible. It's really impossible for humans to find fixed rules how to translate in a good and persuasive manner. It's really a difficult task, and so I think we could go another way. There's a very interesting development in poetry bots, I think. Do you think you can learn from this case studies here? You can there are poetry bots we can for, I think, Bob Dylan or something like that, Bob Dylan style and so on, so far as I could see. Do you think it's possible to train such a bot to create poetry like Ovid, for example?
I guess it's possible. I remember there was a project once, I think it was at the FAZ, write like some important or some famous person, and they would compare your writing style to, I don't know, Kafka's or something.
Yeah.
So of course there is a possibility of kind of mimicking poetry. So if you give a machine all of Ovid, then perhaps the machine could produce Ovid sounding poems. However, I wonder if they would make much sense, or if we would even want them to. I don't quite know. But yes, the style thing is actually, I think, an application that would be useful in classical studies, because it might help us do what the geniuses of classical philology have done, like infer a missing piece or attribute a text to a certain author by some. Well, we can't all be geniuses, and statistics can help us with that. So I guess that may be actually a useful application. In
we have often to do with fragments of poetry and so in our cases, and there may be a helpful form of AI, I think. It's not translation.
Yes, exactly. It's more like recognizing of a specific language patterns for maybe
patterns and so on, and helping us to study fragments. It's a very, very interesting thing. To fill up these gaps in the manuscripts. Yeah.
So that's actually a way of usefully introducing computers into well, the work of classicists, for example.
Yeah. So, any other questions here?
I was actually wondering, from the example you gave from the Google Translate, gendering, stereotyping, whether you have other examples, whether around gender or racial stereotypes, and what might be the ways around this kind of stereotyping when this kind of machinic translation relies on frequency and probabilistic thinking. Are there any ways around this kind of automatic repercussions of stereotypes?
Actually, I really don't know how, because the problem is the data. And if let's just imagine for a moment that all data that we have on the internet has been written by men, then how would you be able to get to some sort of female voice in there? So it's this data gap that we have. I don't really know how to address it, because it's a whole like societal problem. We would have to introduce a lot more texts that would have to come from a very diverse writership, and I don't know if there's a way of automatically countering bias. I really don't know how you would go about that. So and there's tons of examples. I really I can recommend the Invisible Women book for the gender part. I guess you have maybe read it or seen it. Oh God, I think I have it here somewhere. Let me just get it.
Okay.
That's really interesting.
Yeah.
So this is a really nice book about. Can you read
Yes,
that?
Invisible Women.
You can read that. Okay.
Yeah,
So
exposing data bias in a world designed for men.
Okay. Yeah.
Cool.
it is a very interesting book about exactly this kind of data gapping that we encounter as women, but of course we don't only not only women encounter this, but there's a lot of other people who encounter this too. This is what I used when doing my research. But I guess if you just put in Google machine translation and racism or sexism, you'll find tons of examples.
Okay. So, yeah, Konstantin, I think it's another question here.
Yeah, just a small remark on the gender bias thing. There has been some research, at least, on the detection of gender bias, for example, in word embeddings, where they have, and this was also done for Latin, I think, by the people from Italy, from Milan, Rachele Sprugnoli, I think, who showed that in Latin text, there's of course a lot of gender bias, and then people always make these comparisons in vector spaces in AI models, where they say, okay, the word man has the same relation to king as the word woman to queen. This would be the neutral formulation. And then for Latin texts, people were going to show that the word man is to doctor like woman is to nurse, and not to female doctor. So women can only be nurses because they can only have inferior jobs, and men will always be doctors because they won't be nurses. So this is basically what we are facing in ancient texts and in ancient culture, and you know this. But if we manage to detect these kinds of biases, I think we can also try to reverse them. But of course, this is a complex thing to model. But what you could do is to basically walk in the other direction in the vector space and say, okay, we move or we shift the semantics of certain words or texts towards a more diverse or equal surrounding.
Like a waiting process.
Yeah, basically, yes. So I think that's kind of the state of the art. I'm not an expert on gender studies, but I think that this is what people are trying right now. Mm-hmm. And but I have one more question for Nora Götze, if that's okay.
Yeah.
if we step away from trying to translate ancient texts mechanically and try to classify translations. For example, in language learning, we are often trying to teach our students to translate ancient texts. And this is how we assess their skills and their competence. And then we mark errors and so on. So do you think if we just try to classify, is this a good translation, or where is a certain kind of error in the translation? Do you think this is more feasible than actually generating translations completely from a machine?
Well, there's probably something that you as a human always do in rating when rating students' translations. So I guess this is something that you could probably, like, you could create a reference translation and then have some sort of, oh God, what's an Ähnlichkeitswert? You have to, like, the similarity. You can compute the similarity of the translation that the student gave to you to the reference translation. That would be a possibility to. But in the end, a good translation. I'm just guessing here, but when I was in school, I learned Latin like with very fixed phrases for specific, like for the ablative or for any. There's like, oh, there are some sort of default translation, tiny phrases that you would learn to learn the Latin language. And I'm guessing if you start there and then put on a reference translation, and somewhere in the middle of this there should be your students' translations, hopefully.
Thanks.
So I think Thea, you have a remark here? Yes, you gave us some remarks in the chat.
Hello?
Oh, sorry, I don't understand you.
It's not loud enough. It should be... So.
Okay. How about now?
Yeah.
Yeah.
Is this better?
Yeah.
Okay. First of all, thank you very much for your paper. It was really interesting to me, and making super clear something which is incredibly complicated. I wanted to ask, relating to the, automating translation with very few data languages, what your thoughts were of the method that the team at MIT, Luo Bartile, came up with in, I think it was 2019, of automating the translation of languages with very few data by playing on the identification of cognates, using, for instance, the relationship between Greek, Ugaritic, and Linear B.
Actually, I didn't know of that, but it sounds interesting, and it seems to me to go into the direction of what Konstantin said about like linking languages, like using those. Well, as long as it's to not actually translate, but rather get a grasp of the language, I guess it is probably an interesting approach to that.
Languages which haven't been deciphered yet.
I'm sorry?
How about for translating languages which have not been deciphered yet?
Yes, of course. That's another thing that would probably be very interesting, in that you can, well, it is a pattern matching. Oh God, Aufgabe. Task. It's a pattern matching task. I guess that is something definitely that a machine would be useful for. It is all in these last in the last folie slide that I gave. All these six, I found them really useful, these 6 things that the Alpac report suggested for doing with computers. And this seems exactly like a thing that should be at least underscored by computer help.
Thank you very much.
So, any other questions here? Yeah. So, yeah, Julia, should we close, or what do you think? It has been a very lively discussion. I'm very glad about this very lively discussion here.
I would have just a remark on, just a brief remark on James Joyce, Finnegan Wakes, on which has been done a lot actually of, well, I don't know a lot, but at least it has been done computer science experiment on this text. And I Googled it before this session. Let me check if I have, I found, for example, oh no, it's not here anymore. Wait a sec. I found a interesting paper, for example, which was published in Guardian recently, I think a couple of years ago. Now I lost it because I did a copy-paste Mitea link. I wanted to check what they put in the chat, so I lost my link, and it's a pity. Well, anyway, it has been there have been this experiment done on this text, and the surprising result was that the machine was able to compute a lot of fractural, a lot of mathematical fractals, but it was not covering it 100%. So basically, the machine was able to discover a mathematical structure in this language, but was not able to, to compute it all. I find it totally interesting, because usually we think how a machine can compute our language, but we usually don't think that also a human being actually can compute in between literary language. You see what I mean?
Yes. It's interesting because it points to some sort of random human element, which is actually very comforting to know, I think. I mean, James Joyce is, if you don't mind my saying, he's insane with language. So it's interesting really that someone went into this. But actually, there must be some kind of pattern to his insanity, because it is not easy to really create like a random text. I don't know that anyone could do it. So it's probably, if someone goes for this kind of style, it might be easier actually to find a pattern, a mathematical pattern in that, than when you just go about your normal language use, because this is a deliberate attempt at some sort of, well, insanity.
Yeah, I can read the beginning of the, I try to put you, it's really, it's mad. I mean, I have it here. The beginning says, in fact, the beginning of this paper on this research in Guardian said, James Joyce Finnegan Wakes has been described as many things, from a masterpiece to unreadable nonsense. But it is also, according to scientists at the Institute of Nuclear Physics in Poland, almost indistinguishable in its structure from a purely mathematical multifractal.
That is cool.
And I found it amazing that there were even physicists doing this, but I think there is research like that which has been done also on the Ulysses, especially on Penelopes.
Yes.
Like they try to check where a machine would put the interpunction, for example, in this text. And I just find fascinating that we always think about machine and humans in translating language, but there is also already in human language a mathematical mechanical system.
Yes.
In works like Joyce, I found it like, what exactly for the reason that you meant, this random element.
Yes, there's something left, something human.
Something left that you cannot, exactly, something left that you cannot cover 100% through a machinic intervention. Yeah. Yeah, well, then thank you so much, Nora, for your talk, and warmly thank also to you, Roland, for the sharing. Thank you so much for being with us today. In 10 days, meaning on the 26th of February, there will be the last lecture of the series by a colleague of Nora. And yeah, and as I said, there is the lecture of Serafino, which should have been taking place yesterday. It has been postponed to the 15th of March. But when the date will be approaching, then we will send off again emails to the people who contact us personally or friends. So Nora, thank you so much. By the end of the month, we will upload all the recordings. So keep a look on the program. So you will have the recording also of your lecture. And yeah, but that's it basically, unless Sophia would also like to mention something.
Well, just a big thank you, Nora and Roland, for being here with us today. And a big thank you to everybody who joined as well. It was a very interesting discussion. And yes, we'll let you know when we upload the videos, so you can look at yourselves online. Yes.
Yeah. Thanks.
Thank you.
Oh yeah. Thanks to you.